There's a place on Earth where the sun has never shone. Not once in 4 billion years. Not a single photon of daylight has ever touched the creatures that live there. They exist in a darkness so absolute, so crushing, that the weight of the ocean above them would collapse a human skull in seconds. And yet, they thrive, they hunt, they breed, they build ecosystems as complex as any rainforest. But the life that exists there, it doesn't look like life as we know it. Transparent skulls, teeth like daggers longer than the fish's own body, eyes the size of dinner plates or no eyes at all, bodies that glow with their own cold alien light, jaws that unhinge to swallow prey twice their size, skin so black it absorbs 99.9% of light, making them functionally invisible even when they're right in front of you. These aren't creatures from science fiction. They're real. They're evolving right now, miles beneath your feet in the last unexplored wilderness on Earth. This is the deep sea, and the fish that live there look like they're from another world. But they're not. They're from ours. And that might be the most unsettling part. Let's start where the light ends, 200 meters down, about the height of a 60-story building. This is the edge of what we call the twilight zone, the last place where even a trace of sunlight can reach. Stand here, suspended in the water column, and look up. The surface is still visible, a shimmering membrane of silver light. Look down, and there's only blue-black emptiness. A void that goes deeper than Mount Everest is tall. Most people think the ocean is blue, but blue is just what's left after the water has absorbed everything else. Red light disappears first, within 10 meters, then orange, then yellow. By the time you reach 200 meters, the only color that remains is a deep, cold blue. And then, even that is gone. This is where the deep sea fish begin. But here's what's strange. They don't look that unusual yet. At this depth, you'll find fish that seem almost normal. Tuna, swordfish, squid with sleek muscular bodies built for speed because at 200 meters there are still rules. There's still light to see by, still oxygen to breathe, still enough food drifting down from the surface to support large, active predators, but keep descending. 300 meters, 400, 500. The water gets colder. The pressure increases, the light fades to almost nothing, just a faint, ghostly glow like the last embers of a dying star. And the fish begin to change. At around 600 meters, you encounter something called the hatchet fish. It's small, about the size of your thumb, with a body so thin it looks like it's been pressed flat between two panes of glass. Its scales are silver, mirror-like, reflecting what little light remains. But it's the eyes that stop you. They don't sit on the sides of the head like a normal fish. They point upward, huge, tubular. Taking up nearly half the volume of the skull, they look like telescopes. And in a way, they are. These eyes are designed to do one thing: detect the faintest possible silhouette against the surface far above. Because even at 600 meters, even in near total darkness, there's still a difference between up and down. A predator passing overhead will block even the faintest glow of distant sunlight, creating a shadow. And that shadow means food or death. The hatchetfish's eyes are so sensitive they can detect a contrast of just a few photons. They're locked in place, the fish can't move them. So to look in a different direction, the entire body has to tilt. This is the beginning of something you'll see again and again in the deep sea: extreme specialization. In a world with so little energy, you can't afford to be a generalist. You have to be perfect at one thing. The hatchetfish is perfect at looking up. But here's the question scientists still argue about. What is it looking for? Because at this depth, there's barely anything left to see. Unless Something else is looking back. 1,000 meters. You are now deeper than the Eiffel Tower is tall. The pressure is 100 times greater than at the surface. Sunlight is gone, not dim, not faint. Gone. Welcome to the midnight zone. And this is where things get strange. In the absence of sunlight, the deep sea has invented its own. Bioluminescence. 90% of the animals that live in the midnight zone produce light. Not from the sun, not from fire, from their own bodies. They do it through a chemical reaction, luciferin molecules combining with oxygen, catalyzed by an enzyme called luciferase. The result is a cold blue-green glow that costs almost no energy and produces no heat. Some fish have rows of glowing organs called photophores running along their bellies, tiny bioluminescent lanterns that light up the underside of their bodies. Why? To erase their own shadow. When seen from below, a fish's silhouette is one of the most visible things in the ocean. But if you produce just enough light to match the faint glow from above, you disappear. You become invisible. This is called counter-illumination camouflage. Other fish use light as a lure. The anglerfish, perhaps the most famous deep-sea predator, has a glowing bulb that dangles in front of its mouth like a lantern on a fishing rod. The light attracts curious prey which swim closer and closer until the anglerfish's jaws snap shut like a bear trap. But here's where it gets eerie. Some fish don't produce their own light. They farm it. The flashlight fish, for example, has pockets beneath its eyes filled with bioluminescent bacteria. Millions of them living in a symbiotic relationship with the fish. The fish provides them with food and shelter. In return, the bacteria glow. The fish can control the light by covering the pockets with a flap of skin, like closing a shutter. Flash, 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 a signal in the dark. But to who? Scientists still don't fully understand what many of these light displays mean. Some are warnings, some are mating signals. Some seem to serve no purpose we can identify. And some we've only seen once. In 2019, researchers captured footage of a fish they'd never seen before. It had glowing stripes running vertically down its body, pulsing in a rhythmic pattern. The light moved like a wave, from head to tail, over and over. They don't know what species it was. They don't know where it went. They never saw it again. Now let's talk about the fish you can't see. In 2020, a team of scientists studying deep-sea creatures made a disturbing discovery. They found a fish with skin so black it absorbed 99.5% of all light that touched it. Blacker than black, blacker than velvet, blacker than charcoal. In fact, it's one of the darkest materials ever found in nature, comparable to Vantablack, the synthetic substance developed for stealth technology. Under normal light, this fish looks like a hole in reality, a void-shaped creature. You can't see its features, you can't see where its body ends and the background begins. It's like looking at a living shadow. The fish achieves this through microscopic structures in its skin, tiny melanin particles arranged in a specific pattern that traps light and prevents it from reflecting. Any photon that hits the skin bounces around inside these structures until it's absorbed completely. Why would a fish need to be this invisible? Because in the deep sea, even the faintest reflection can get you killed. Remember, most deep-sea predators hunt using bioluminescence. They shine a light into the darkness searching for prey. If your skin reflects even a fraction of that light, a glint, a sparkle, you're visible, you're dead. So these fish have evolved to become invisible even under direct illumination. But here's the truly strange part. These fish still have eyes, which means they're trying to see other creatures, who are also trying not to be seen. In an environment where both predator and prey are functionally invisible. It's an evolutionary arms race played out in absolute darkness. And we're only just beginning to understand the rules. At 1,500 meters, you encounter the fangtooth. It's not a large fish, about 6 inches long, but its teeth are half an inch each. That's proportionally longer than a great white shark's. The fangtooth's teeth are so large they don't fit inside its mouth. When it closes its jaws, the bottom fangs slide into special sockets in the roof of its skull, right next to its brain, to keep them from piercing its own head. This fish is built to kill prey larger than itself. But here's the problem. At this depth, prey is rare. You might go weeks without encountering another animal. So when you finally do find something to eat, you can't afford to let it escape. The fangtooth doesn't chase, it doesn't stalk. It simply waits. Drifting in the current, jaws slightly open, hoping that something, anything, will swim close enough. And when it does, those jaws snap shut with enough force to impale prey through the spine. But the fangtooth isn't the only nightmare down here. There's the viperfish with teeth so long it can't close its mouth. There's the gulper eel with a jaw that unhinges to form a massive gaping pouch, allowing it to swallow prey several times its own size. There's the black swallower, which can consume fish so large that the prey remains visible through its distended, transparent stomach. These aren't normal predators, they're famine predators. In a world where food is almost non-existent, evolution has created creatures capable of eating anything and surviving for months on a single meal. But that raises a question. If food is so rare, how do they find each other to reproduce? And the answer is disturbing. 4,000 meters. You are now deeper beneath the ocean's surface than most of Earth's mountains are tall. The pressure is nearly 400 times atmospheric pressure. The temperature hovers just above freezing. You are in the abyssal zone, and life here barely makes sense anymore. Let's return to the anglerfish. You've probably seen pictures of it. The grotesque, bulbous predator with the glowing lure and the nightmare jaws. But here's something you probably don't know. That's the female. The males are different. Male anglerfish are tiny, sometimes 100 times smaller than the female. They don't have glowing lures. They don't have functional stomachs. They barely have eyes because they don't need them. When a male anglerfish hatches, he has one purpose: find a female. He follows her scent trail through the dark, swimming blindly, desperately, because his body is burning through its limited energy reserves. When he finally finds her, he bites into her skin. And then he fuses. His body releases enzymes that dissolve his mouth and her flesh, merging the two organisms at the cellular level. His circulatory system connects to hers. His organs atrophy: heart, eyes, brain, until all that remains is a pair of testes dangling from the female's body like a parasitic lump. He lives the rest of his life as a biological appendage. Some females have multiple males fused to them, 6, 8, 10, each one a living sperm bank, permanently attached, slowly being absorbed. It's one of the most extreme examples of sexual dimorphism in the animal kingdom. But it makes sense. In a world where encountering another member of your species might be a once-in-a-lifetime event, you can't afford to let them go. So evolution found a way to make sure they never do. Here's a fish called the barreli. It has a transparent skull. You can see its brain. The skull is a fluid-filled dome like a fighter jet canopy, and inside it, 2 tubular eyes point upward, staring through the top of its own head. For decades, scientists thought this fish was broken. Every time they brought one to the surface in a net, the skull would rupture, the eyes would be damaged, and the fish would die before they could study it. It wasn't until 2004 that researchers finally captured footage of a living barreli in its natural habitat, and they realized the transparent skull isn't a flaw, it's the whole point. The barreli drifts in the water column, motionless, staring upward through its own head. Its eyes track the faint silhouettes of jellyfish and other prey drifting above. When it spots something, it tilts its entire body upward, and its eyes rotate forward inside the skull so it can see where it's going as it swims toward its prey. A fish with a transparent head, with eyes that rotate inside its skull. This isn't alien life, this is Earth life, and it raises an uncomfortable question. If life on Earth can evolve to look like this, what else is possible? Down here in the abyss, time moves differently. The Greenland shark, for example, grows at a rate of less than 1 centimeter per year. Some individuals alive today were born before Shakespeare was writing. They don't reach sexual maturity until they're 150 years old. They move slowly, they metabolize slowly, they live slowly. Because in the deep sea, energy is everything. Food is so scarce that an average deep-sea fish might consume only a few grams of food per year. Their metabolism is so slow that some species can survive for months without eating. Their heart rates are measured in beats per minute, not per second. They are living in slow motion. And this has an eerie effect. Many deep-sea fish don't experience time the way we do. A year in the abyss might feel like a week. A decade might pass like a season. These are creatures that exist on geological timescales. But here's what scientists still don't understand. How do they know when to reproduce? There are no seasons down here, no lunar cycles, no day or night. The environment is unchanging, and yet somehow populations of deep-sea fish synchronize their reproduction. Millions of individuals scattered across thousands of miles of ocean all spawn at the same time. How? We don't know. There's something they're responding to. Some signal we can't detect, some rhythm we can't perceive. A deep-sea mystery that remains unsolved. Let's go deeper. 6,000 meters, 7,000, 8,000. You are now in the Hadal Zone, named after Hades, the Greek underworld, the trenches. At these depths, the pressure is over 1,000 times atmospheric pressure. It would crush a submarine. And yet fish live here. The deepest fish ever recorded was found at 8,278 meters in the Mariana Trench. A snail fish, pale, ghostly, with translucent skin and no scales. It looks fragile, delicate, like it would fall apart if you touched it. But it's one of the toughest organisms on Earth. How does it survive pressure that would liquefy a human body? The answer lies in biochemistry. Deep-sea fish don't have air-filled cavities, no swim bladders, no lungs. Their bodies are made of incompressible materials: water, fat, gelatinous tissues. The pressure outside their bodies is matched by the pressure inside. They also produce a molecule called trimethylamine N-oxide, or TMAO. This compound stabilizes proteins under extreme pressure, preventing them from collapsing. But here's the limit. TMAO only works up to a certain depth. Around 8,200 meters, even with TMAO, proteins start to break down. This is called the biological depth limit. Below 8,200 meters, fish, as we understand them, cannot exist. But other life can. Single-celled organisms, amphipods, creatures so alien that we're still trying to figure out if they should be classified as animals at all. And here's the question that keeps scientists awake at night. If life can exist at the absolute limit of what chemistry allows on Earth, what's stopping it from existing in even stranger places? Beneath the ice of Europa, in the sulfuric clouds of Venus, in environments we haven't even imagined yet? The deep sea isn't just teaching us about fish. It's teaching us about the limits of life itself. We've been studying the deep sea for over a century. We've sent submersibles to the deepest trenches. We've deployed cameras, sensors, remotely operated vehicles. We've cataloged thousands of species. And yet here's the truth. We've explored less than 5% of the ocean floor. Every time we send a camera down, we discover something new. New species, new ecosystems, new forms of life that shouldn't exist. In 2020, researchers discovered a fish with antifreeze proteins in its blood, allowing it to survive in water cold enough to form ice crystals inside its body. In 2021, they found a species of octopus that broods its eggs for 4.5 years, the longest gestation period of any animal on Earth. In 2023, they recorded sounds from the deep sea that they still can't identify. Low-frequency pulses, rhythmic patterns. Something is making noise down there. But what? Scientists have more questions now than they did 50 years ago. How do deep-sea fish find mates in total darkness across thousands of miles of ocean? How do they navigate? How do they know where they are? How do they communicate? Some researchers believe there's an entire language of bioluminescent signals we haven't decoded yet. Others think there are magnetic or chemical cues we can't detect. But no one knows for sure. And every answer raises 10 new questions. So why do deep-sea fish look like they're from another world? Because in a way, they are. The deep sea is as alien to us as the surface of Mars. More alien in some ways because Mars is dry and dead while the deep sea is teeming with life. Life that has evolved under rules we barely understand. These fish look strange because they're the product of 4 billion years of evolution in an environment we never see. They've been shaped by pressures and forces that don't exist on land. They've developed solutions to problems we've never had to face. Invisible skin, transparent skulls, teeth longer than their bodies, eyes that see in the dark, light without fire, parasitic reproduction. They look alien because they've had to become something other than what we think of as normal. But here's the unsettling part. They're not aliens. They're our relatives. Every fish in the deep sea shares a common ancestor with you. Somewhere in the fossil record, your lineage and theirs split apart. One branch climbed onto land, grew lungs, and eventually became you. The other branch stayed in the ocean, went deeper and deeper and deeper until it became this. And that means the capacity for this kind of strangeness, this kind of alien beauty was always there, waiting, lurking in the code of life itself. Which raises one final question. If evolution can turn a fish into that, what could it turn us into? Given enough time, enough pressure, enough isolation, what could we become? The deep sea is still there. Right now, miles beneath your feet, creatures are glowing in the dark, hunting, hiding, evolving, becoming something we haven't discovered yet. The ocean covers 70% of our planet, and we've barely looked. Imagine what else is down there, waiting,